Do you still remember Rutherford atomic theory? In Rutherford's atomic theory, an atom consists of a positively charged nucleus with electrons moving around it. This atomic model became debatable. If the electron moved fast in a circular path, then it would radiate energy. If the electron keeps moving, then all the energy of the electron would get over, that causing the electron to move in a spiral into the nucleus, and the atom will collapse. However, all these things do not happen in an atom. And why we say so? That because in nature, all atoms are stable. In 1913, Niels Bohr tried to solve this problem using an emission spectrum of hydrogen. What is the emission spectrum? Here we have a hydrogen discharge tube, a slim tube containing hydrogen gas. If we energize hydrogen gas with high voltage, the tube lights up with a bright pink colors. This color consists of 4 specific colors. Our eyes, however, are not able to see the 4 individual colors. We can see those 4 colors using a prism. Remember that the prism can break white light of the sunlight into the rainbow color. The same thing happens into the hydrogen light. If we place a slit and a prism, the pale pinkish color of hydrogen will pass through the slit and disperse or spread out into 4 different colors: violet, blue-green, and red. We call these 4 colors as an emission spectrum of hydrogen. Spektrum in bahasa is rentetan warna kontinu yang diperoleh apabila cahaya diuraikan ke dalam komponennya. The 4-color spectrum of hydrogen has a specific wavelength. The violet light at 410 nanometers, the blue-violet in 434 nanometer, the blue-green in 486 nanometer, and the red, the last one, 656 nanometer. Please take a look at the real demonstration of hydrogen spectra by the physics demo lab.
So this is hydrogen. It has a reddish cast to it, and when the diffraction grating is in place, you'll see lines.
The emission spectrum of hydrogen shows the movement of the electron within the hydrogen atom. Based on this emission, Niels Bohr assumed that first, the electron in a hydrogen atom travels around the nucleus in a circular orbit. The energy of the electron in an orbit is proportional to its distance from the nucleus. The farther the electron from the nucleus, the more energy it has. Third, the electron can only exist at a specific energy level and cannot exist at energy in between those discrete energy. In other words, the electron is quantized. Quantized electron means that the electron can only exist at specific energy level and never at any other energy. Fourth, light is absorbed when an electron jumps to a higher energy orbit and emitted when an electron falls into a lower energy orbit. Let's take a look at this atom. When atom energized, the electron will absorb energy and cause the electron to jump into the higher energy level. When the electron back to the lower energy level that more stable, it will emit energy. The emission spectrum of hydrogen shows the movement of the electron within the atom. The transition from the third orbit into the second orbit will emit red light. The transition from the fourth orbit into the second orbit will emit blue-green light. The transition from the fifth orbit into the second orbit will emit blue-violet light. The transition from the sixth orbit into the second orbit will emit violet light. The electron can only absorb specific energy. This specific energy equal to the difference between the energy of the orbits. Each element has its unique spectrum. Like a fingerprint that can be used to identify a person, the emission spectrum can be used to identify an element. Then, what happens to our red apple? When apple get energy from the sun, which is white light that consists of the rainbow color, electrons inside the atoms of the apple will absorb just specific energy. Then, the rest of the color will be reflected into our eyes. In this case, the green light is absorbed and the others are reflected and we see as a single color, red. The Bohr model worked beautifully for explaining the hydrogen atom. Unfortunately, it didn't fit the complex atoms. So, the history of the atomic theory is not ending yet.